Alright, so in this problem, I have 45 to the power of x is equal to 90. So to solve this, I'm going to first start by taking the log on both sides. So now I have log 45 to the power of x is equal to log 90. Now, if I have something in the form log a to the power of b, I can actually move this exponent b to the front. So this is the same thing as b times log a. So in this case, I have log 45 to the power of x, and I can move x to the front. So now this is the same thing as x times log 45, which is equal to log 90. Now, if I divide both sides by log 45, these two cancel out, and now I have x is equal to log 90 over log 45. Log 90, that's the same thing as log 2 times 45. So I have this over log 45. And if I have something in the form log a times b, this is the same thing as log a plus log b. So now I have x is equal to log 2 plus log 45. Now I have this over log 45. So now this is equal to log 2 over log 45 plus log 45 over log 45. And now log 45 and log 45, these two cancel out. So now I have x is equal to log 2 over log 45 plus 1. And if I have something in the form log a over log b, I can write this as log base b of a. So log 2 over log 45, that's the same thing as log base 45 of 2, and I have this plus 1. Alright, so in this problem, I have 3 to the power of x plus 9 to the power of x is equal to 27 to the power of x. So to solve this, I'm going to first start by rewriting 9 to the power of x as 3 squared to the power of x, and 27 to the power of x as 3 to the power of 3 to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So I can rewrite these as 3 to the power of x plus 3 to the power of x to the power of 2 is equal to 3 to the power of x to the power of 3. Now I'm going to let 3 to the power of x equal to y. So now I have y plus y squared is equal to y to the power of 3. And this cannot be written as y to the power of 3 minus y squared minus y is equal to 0. Now if I factor out y, I get y times y squared minus y minus 1 is equal to 0. So this gives me two equations. I get y equals 0 and y squared minus y minus 1 is equal to 0. So for y squared minus y minus 1 equals 0, I'm going to use the quadratic formula. And if you do end up doing it, you should get y is equal to 1 plus or minus the square root of 5 over 2. So my solutions for y are 0, 1 plus the square root of 5 over 2, and 1 minus the square root of 5 over 2. Now remember how we set 3 to the power of x equal to y. So I have 3 to the power of x is equal to 0. This is our first value of y, and you can't take the power of a number and make it equal to 0, so this is wrong. Now I have 3 to the power of x is equal to 1 minus the square root of 5 over 2, and you can't, 1 minus the square root of 5, that's going to be a negative number, and you can't take the power of a positive number and make it a negative number, so this is wrong as well. So I'm left with 3 to the power of x is equal to 1 plus the square root of 5 over 2. So to solve this, I'm going to take the log on both sides, so I have log 3 to the power of x is equal to log 1 plus the square root of 5 over 2. Now I can move this to the front, so now I have x times log 3 is equal to log 1 plus the square root of 5 over 2. And if I divide both sides by log 3, I get x is equal to log 1 plus the square root of 5 over 2 over log 3. Alright, so in this problem, I have 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 999. So to solve this, I'm going to first start by factoring out 3 to the power of x. So now I have 3 to the power of x times 1 plus 1 plus 1 is equal to 999. Now 1 plus 1 plus 1, that's equal to 3. So now I have 3 to the power of x times 3 is equal to 999. Now I'm going to go ahead and divide both sides by 3. So then these two cancel out, and I have 3 to the power of x is equal to 111. Now if I take the log on both sides, I have log 3 to the power of x is equal to log 111. And if I have something in the form log a to the power of b, I can move this exponent and b to the front. So this is equal to b times log a. So for log 3 to the power of x, I can move x to the front. So now I have x times log 3 is equal to log 111. Now if I divide both sides by log 3, these two cancel out. And now I have x is equal to log 111 over log 3. Oops, sorry, I think I made a mistake here. 999 divided by 3 is actually 333, not 111, so this is going to be log 333 over log 3. And now I'm going to rewrite log 333 as log 111 times 3 over log 3. And if I have something in the form log a times b, this is equal to log a plus log b. So log 111 times 3, that's going to equal to log 111 plus log 3 over log 3, which is the same thing as log 111 over log 3 plus log 3 over log 3, which is 1. And log 111 over log 3, that's the same thing as log base 3 of 111, so this plus 1, so this is my answer.